It was a rifle pulled directly from the pages of science fiction. A blocky, olive-drab monolith that promised to redefine infantry combat for the 21st century. The Heckler & Koch G11 was not just another firearm. It was a revolution encapsulated in a polymer shell. It fired ammunition without a case, spat out bullets at a speed the human mind could barely register, and offered a level of theoretical accuracy that seemed impossible. It was supposed to be the weapon that would give NATO soldiers an undeniable edge on the battlefields of a potential World War III. For decades, it was the next big thing, the subject of whispers and wonder in military circles. It was tested, refined, and even on the verge of adoption, and then, it vanished. The G11 became a ghost, a spectacular technological marvel, relegated to museums and the collections of a few very fortunate individuals. Why did a rifle that represented such a monumental leap forward ultimately fail? How could a weapon system that absorbed hundreds of millions of Deutschmarks in development and decades of engineering genius end up as a footnote in firearms history instead of the new standard? The story of the G11 is not just about a gun. It is a story about ambition, the harsh realities of military logistics, the unpredictable currents of history, and the immense difficulty of turning a brilliant idea into a practical tool of war. The G11 stands as a testament to a specific kind of technological optimism, a belief that any problem could be solved with enough ingenuity and resources. It challenged the very foundation of firearm design, a foundation that had remained largely unchanged for over a century, since the advent of the self-contained metallic cartridge. It asked a simple yet profound question: what if we could get rid of the brass case? The answer to that question led HK down a path of incredible innovation, creating a mechanism so complex and unique that it has been aptly nicknamed Kraut space magic by enthusiasts. It was a marvel of clockwork precision, a Swiss watch of a rifle. But as with many tales of revolutionary technology, the G11's greatest strengths were intrinsically linked to its greatest weaknesses. Its ambition was both its driving force and the seed of its own demise. To understand why this futuristic weapon never armed the soldiers of the Cold War, we must look beyond the rifle itself. We must examine the era that created it, the technical hurdles it could not overcome, and the political earthquake that ultimately rendered its purpose obsolete. The G11 was a perfect weapon for a war that was never fought, and its failure is as fascinating and instructive as its design. The story of the G11 begins in the tense, divided world of the Cold War. By the late 1960s, the battle lines in Europe were firmly drawn. On one side stood the forces of NATO, and on the other, the vast armies of the Warsaw Pact. Military planners on both sides were locked in a perpetual arms race, constantly seeking a technological advantage that could tip the balance in a potential conflict. The standard infantry rifle was a key focus of this race. The Soviets had their AKM, a simple, rugged, and reliable weapon. The Americans had the M16, a lighter, more accurate rifle firing a smaller, high-velocity projectile. Germany, a frontline state in this standoff, was looking for its own next-generation solution. The German Bundeswehr, along with its NATO allies, was grappling with a concept known as the hit probability problem. Studies conducted during and after World War II revealed a sobering truth. The average soldier in a high-stress combat situation was remarkably unlikely to hit their target with a single aimed shot. The key to increasing lethality was not necessarily to make the soldier a better marksman, but to increase the number of projectiles sent downrange in the shortest possible time. If a soldier could fire a multi-round burst so quickly that the rifle did not have time to move from recoil, the chances of at least one of those bullets hitting the target would skyrocket. This was the theory that would drive rifle development for decades. This quest for increased hit probability led to various programs, like the American Special Purpose Individual Weapon Project, which explored fléchette firing rifles. In Germany, the Ministry of Defense initiated a study for a new assault rifle to eventually replace their excellent but heavy 7.62 51mm HK G3. They wanted a weapon that was lighter, had less recoil, and, most importantly, could dramatically improve the hit probability of the average infantryman. This was not just a request for a better gun, it was a demand for a paradigm shift in small arms technology. They were no longer content with simply refining existing designs. They wanted a revolution. Heckler & Koch, already a premier firearms manufacturer, renowned for its innovative engineering, took up this challenge. Partnering with Dynamit Nobel, a company with deep expertise in propellants and ammunition, H&K began to explore the most radical idea of all caseless ammunition. The logic was clear. If you could eliminate the metallic cartridge case, you could solve several problems at once. The ammunition would be significantly lighter and smaller, allowing a soldier to carry more. Furthermore, the rifle's mechanism could be simplified by removing the need to extract and eject a spent case, a complex and often problematic cycle of operations in any automatic firearm. This was the genesis of the Gewehr 11, or G11. At the heart of the G11's revolutionary design was its ammunition. The 4.73 by 33 mm caseless round was a marvel of chemical and materials engineering. It consisted of a rectangular block of high ignition temperature propellant, shaped kind of like a small chocolate bar. The primer was seated at the base and the bullet itself was embedded entirely within the propellant block. This solid block of propellant was the case. There was no brass to extract, no metal to eject. This single innovation dictated the G11's entire form and function, leading to one of the most unconventional firearm mechanisms ever devised. It was a complete departure from everything that had come before. The G11's action was as unique as its ammunition. Instead of a traditional bolt that moves back and forth, the rifle featured a rotating chamber, part of a mechanism that cycled vertically and horizontally within the weapon's housing. When the trigger was pulled, the entire internal mechanism, barrel, chamber, and magazine, would recoil backward inside the outer polymer shell. For a 3-round burst, the action would cycle 3 times with phenomenal speed, loading and firing 3 rounds before the internal assembly completed its rearward travel. The firer would perceive the recoil of all 3 shots as a single push, not 3 distinct impulses. This hyperburst feature was the key to improving hit probability. Feeding this strange mechanism was equally futuristic. The ammunition was loaded into a long, single-stack magazine that held 45 or 50 rounds. This magazine was not inserted from below like a conventional rifle, but was laid horizontally on top of the barrel, with the bullets pointing downwards. When the weapon cycled, the rotating chamber would turn 90 degrees to align with the magazine. A new round would be pushed down into the chamber, and the chamber would then rotate back into alignment with the barrel, ready to fire. This top-mounted feeding system contributed to the rifle's strange, blocky profile and was a necessary solution for handling the unconventional ammunition. Ergonomically, the G11 was a product of its internal layout. It was a bullpup design, with the action and magazine located behind the trigger group, allowing for a long barrel in a compact overall package. The entire rifle was encased in a futuristic-looking polymer shell designed to protect the complex internal mechanism from the elements and the rigors of combat. It featured an integrated carrying handle with a simple optical sight, as a high-magnification scope was deemed unnecessary for a weapon designed around burst fire at typical engagement ranges. The charging handle was a rotary knob on the side, adding to the rifle's unconventional feel. It looked and felt like nothing else on Earth. The G11's design offered a tantalizing set of advantages over traditional rifles like the American M16 and the Soviet AK-74. The most significant of these was its revolutionary 3-round hyperburst capability. Firing at a cyclical rate of over 2,000 rounds per minute, the G11 could place 3 projectiles on a target before the shooter's body had time to react to the recoil. In theory, this meant that wherever the sights were pointed for the first shot, all 3 would land in a very tight cluster. For a soldier under the immense stress of combat, this transformed aiming from a precise, single-shot exercise into simply pointing the weapon in the general direction of the enemy and pulling the trigger once. The second major advantage was rooted in its caseless ammunition. By eliminating the heavy brass case, the 4.73 by 33 mm ammunition was approximately 50% lighter than equivalent brass-cased 5.56 by 45 mm NATO ammunition. This translated into a massive logistical benefit. An infantryman could carry significantly more ammunition for the same weight, effectively increasing his combat endurance and firepower without adding to his burden. For a military planner, this meant supply lines were less strained, and squads could sustain firefights for longer periods. The ammunition was also more compact, allowing the G11 to have a standard magazine capacity of 45 or 50 rounds, a substantial increase over the 30-round standard of the M16 and AK-74. Furthermore, the G11's unique free-floating action and bullpup configuration offered superior control and potential accuracy. In semi-automatic mode, the entire internal assembly recoiled within the housing, creating a very gentle and delayed recoil impulse that was far more manageable than that of a conventional gas-operated rifle. This made it a very stable and comfortable shooting platform. The bullpup layout allowed for a relatively long barrel compared to its overall length, preserving muzzle velocity and ballistic performance in a weapon that was shorter and more maneuverable than a standard M16 rifle, making it ideal for the tight confines of urban combat or mechanized infantry operations. Finally, by eliminating the need for an ejection port, the G11 was a truly ambidextrous weapon system right out of the box. There were no hot brass casings flying out to hit a left-handed shooter in the face. The design was inherently sealed from the outside environment, making it theoretically more resistant to the ingress of dirt, sand, and mud, the mortal enemies of any infantry rifle. On paper, the G11 was a masterpiece. It was lighter, carried more ammunition, offered a higher probability of hitting its target, was more compact, and was more reliable in adverse conditions. It was, in almost every measurable way, the superior weapon. Despite its theoretical superiority, the G11 was plagued by a series of practical problems that, honestly, proved incredibly difficult to solve. The most significant of these was heat management. In a conventional firearm, a significant amount of heat from the burning propellant is absorbed by the brass cartridge case, which is then ejected from the weapon. The G11 with its caseless ammunition had no such mechanism for heat removal. So all of the heat from firing just stayed inside the rifle, concentrated in the chamber and barrel. During sustained fire, the chamber could become so hot that it would prematurely ignite the propellant of a chambered round, a dangerous phenomenon known as a cook-off. The ammunition itself presented another major hurdle. The solid block of propellant, while revolutionary, was also pretty fragile. Early versions of the caseless rounds were susceptible to cracking or breaking during rough handling, which could lead to catastrophic malfunctions in the rifle's complex mechanism. Furthermore, the propellant had to be completely sealed from moisture and ambient humidity, since any absorption could alter its burning properties and affect performance. Dynamit Nobel spent years reformulating the propellant to make it more durable and resistant to heat, eventually creating the high ignition temperature propellant, or HITP, but the fundamental fragility and vulnerability of the ammunition remained a persistent concern for military evaluators. Then, there was the sheer complexity and cost of the system. The G11's internal mechanism was a marvel of engineering, but it was also incredibly intricate, kind of like the workings of a mechanical watch. This complexity raised some serious questions about its field serviceability. A simple malfunction that could be cleared in seconds on an M16 or AK-74 might require a trained armorer to disassemble the G11's entire internal chassis. This made it a logistical nightmare for an army that relies on soldiers being able to maintain their own weapons in the field. The manufacturing process was also astronomically expensive, not only for the rifle, but for the specialized ammunition, which required entirely new production facilities. Finally, the problem of clearing a dud round was a significant design flaw. In a traditional rifle, a misfired cartridge can be easily ejected by manually cycling the action. In the G11, a dud round remained stuck in the chamber. The rifle had a mechanism to essentially skip over it and load a fresh round, but this meant the dude was still inside the hot chamber, creating a very real risk of a delayed ignition or cook-off. Clearing it required pointing the rifle in a safe direction and manually operating a tool to eject the faulty round through a port at the bottom of the rifle. This was a slow, awkward, and potentially dangerous procedure to perform in the heat of combat. So, all these practical issues began to overshadow the rifle's theoretical advantages. By the late 1980s, after nearly 2 decades of development, the HK G11, now in its K2 iteration, was finally ready for formal military trials. The West German Bundeswehr was the primary customer, and the rifle was subjected to a rigorous battery of tests designed to simulate the harsh realities of the modern battlefield. The G11 performed impressively in some areas. Testers lauded its accuracy, especially the effectiveness of the 3-round hyperburst, which demonstrably increased hit probability over the legacy G3 rifle. The soft recoil and excellent ergonomics also received high marks. For a time, it really seemed as though the G11 was on the cusp of success. However, the trials also highlighted the persistent problems that had dogged the program from the start. Concerns about ammunition durability, and, most critically, the risk of cook-offs during sustained fire remained. While the new HITP ammunition was more resistant to heat, it had not entirely eliminated the problem. The rifle's internal complexity was another major point of contention. Soldiers found it difficult to maintain in the field, and the procedure for clearing malfunctions was deemed too cumbersome for a standard-issue infantry weapon. The military was accustomed to rifles that could be stripped and reassembled with minimal tools, and the G11's sealed, intricate nature ran contrary to this doctrine. Simultaneously, the G11 was submitted for evaluation in the NATO trials to select a new standard small-caliber cartridge. This was a critical juncture. If the 4.73mm caseless round were adopted by NATO, it would have ensured the G11's future. Unfortunately, the G11 was essentially a proprietary system. The ammunition was inseparable from the rifle. NATO was looking for a cartridge, not an entire weapon system, and the member nations were heavily invested in their existing 5.56 by 45mm rifles. The radical nature of caseless technology was a logistical bridge too far. Ultimately, a Belgian-designed 5.56mm round, the SS-1009, was chosen as the new NATO standard, effectively isolating the G11 and its unique ammunition. Despite the NATO setback, the Bundeswehr pushed forward. In 1990, the G11 passed its final field trials, and the German government made the momentous decision to formally adopt it. Plans were drawn up to procure nearly 300,000 rifles to begin re-equipping the army. Heckler & Koch had done it. After decades of work and immense financial investment, their futuristic rifle was set to become a reality. It was a moment of triumph, a validation of their radical vision. But history, as it often does, had other plans. The G11 stood at the finish line only to have the entire racetrack disappear from beneath it. While the HK G11 failed to arm the soldiers of the real world, it found a vibrant and lasting second life in the virtual one. For video game developers in the 1990s and 2000s, the G11 was the perfect weapon to signify advanced or futuristic technology. Its bizarre, blocky appearance and its signature 3-round burst function made it an instantly recognizable and unique addition to any virtual arsenal. From classic first-person shooters to sprawling role-playing games, the G11 became a staple for players looking for something exotic and powerful. Its inclusion in these games introduced the rifle to a new generation long after its real-world development had ceased. The rifle's appearance in games like the Siphon Filter series, Fallout 2, and most famously, Call of Duty Black Ops, cemented its status as a piece of iconic firearms lore. In these digital worlds, the G11's real-life shortcomings were irrelevant. Cook-offs, ammunition fragility, and maintenance complexity didn't exist in the code. Players were left with the pure, idealized version of the weapon, a high-capacity, laser-accurate rifle with a devastatingly fast burst. This digital fame created a feedback loop, driving interest among firearms enthusiasts who learned about the rifle through games and then sought out information about its fascinating real-world history. Beyond video games, the G11 maintains a legendary status within the gun enthusiast community. It represents a what-if moment in firearms history, a tantalizing glimpse of an alternate future. Because so few were ever made, and even fewer exist outside of military museums or HK's own collection, the G11 has an almost mythical aura. It is the ultimate unicorn gun, a piece that is virtually unobtainable. This scarcity, combined with its revolutionary technology, makes it one of the most discussed and sought-after firearms among serious collectors and historians. It is, in many ways, more famous today than it was during its development. The G11's story is a powerful draw for those fascinated by the intersection of engineering and history. Documentaries, articles, and online forums are filled with deep dives into its complex mechanism and development saga. For many, the rifle is not just a failed prototype, but a symbol of bold, out-of-the-box thinking. It serves as a case study in technological ambition, a lesson in how even the most brilliant engineering can be stymied by practical realities and the shifting tides of geopolitics. Its legacy is not that of a battle-proven tool, but of a legendary idea that continues to capture the imagination. Just as the HK G11 was poised for adoption by the German military, the world changed in a way no one had predicted. On November 9, 1989, the Berlin Wall fell. This single event triggered a chain reaction that led to the collapse of the Warsaw Pact and the dissolution of the Soviet Union. The Cold War, the very conflict that had spawned the G11 program and justified its enormous expense, was suddenly over. The specter of massive tank armies pouring through the Fulda Gap vanished, and with it, the urgent need for a revolutionary new infantry rifle designed to counter them. The reunification of Germany in 1990 placed an immense financial strain on the nation's budget. The cost of integrating East Germany's economy and infrastructure was staggering. In this new fiscal environment, military spending came under intense scrutiny. The G11 program, with its astronomical price tag, became an easy target for budget cuts. The cost of procuring hundreds of thousands of new rifles, along with the entirely new logistical and production infrastructure for its unique caseless ammunition, could no longer be justified. The primary threat had disappeared, and the government had far more pressing financial priorities. Furthermore, the reunification presented the German military with an unexpected windfall. The Bundeswehr inherited the vast armories of the former East German National People's Army. This included hundreds of thousands of AK-74 rifles and an immense stockpile of 5.45 by 39mm ammunition. Faced with the choice between spending billions on the unproven G11 system or simply using the perfectly serviceable and readily available AKs, the decision was a simple one. The German government cancelled the G11 procurement contract in 1993, citing both the changed strategic situation and the prohibitive cost. Heckler & Koch, having poured decades and a fortune into the project, made a last-ditch effort to salvage the G11. They developed a version chambered for the new 5.56mm NATO standard, but this defeated the entire purpose of the caseless design. The core innovations were lost, and the rifle became just another complex and expensive 5.56mm bullpup. With no customers and no path forward, the G11 program was officially terminated. It was not a single technical flaw that killed the rifle in the end, but a political and historical earthquake. The G11 was a weapon designed for a world that, in a few short years, ceased to exist. The story of the HK G11 is a dramatic tale of a future that never arrived. It was a weapon system that was arguably too ambitious, too complex, and too far ahead of its time. It sought to solve the fundamental problems of infantry combat with a solution of breathtaking ingenuity. By all theoretical metrics, it succeeded. It offered lighter ammunition, a higher magazine capacity, and an almost unbelievable improvement in hit probability through its hyperburst technology. The G11 was a brilliant answer, but the materials, science, and political stability of its era could not fully support the question it was asking. It was a 21st century rifle stuck in a 20th century world. The ultimate failure of the G11 was not due to a single cause, but a confluence of factors. The technical challenges of heat dissipation and ammunition fragility were significant and were never completely solved to the satisfaction of military logisticians. The rifle's clockwork complexity was a nightmare for field maintenance, and its astronomical cost was a difficult pill to swallow even before the end of the Cold War. When the Berlin Wall fell, it removed the G11's entire reason for being. The geopolitical shift, combined with the immense cost of German reunification, delivered the final, decisive blow. The G11 died, not with a bang, but with the stroke of a pen in a budget meeting. Yet, the dream of caseless ammunition did not die with the G11. The advantages it offers, lighter weight, higher capacity, and simplified weapon mechanics, are just as compelling today as they were in the 1980s. Military forces around the world are still searching for ways to lighten the soldiers' load and increase their effectiveness. The United States military's recent next-generation squad weapon program, while ultimately selecting a case-telescoped hybrid ammunition, shows that the quest for a lighter, more efficient cartridge is very much alive. The lessons learned from the G11's propellant and heat management challenges are invaluable to modern researchers. So, does caseless ammunition have a future? Perhaps. The G11 proved that the concept is mechanically viable, even if the material science of its day wasn't quite ready. With advancements in polymers, propellants, and manufacturing, a modern, caseless system might finally be able to overcome the hurdles that doomed its famous predecessor. The HK G11 remains a monument to engineering ambition, a ghost of a future that might still come to pass. It stands as a powerful reminder that sometimes, being revolutionary is not enough. You also have to be practical, affordable, and on the right side of history.